Hey everyone, welcome back. In today's video, we are going to discuss about mean deviation about median. We have already seen what mean deviation about mean is and how it is constructed in individual, discrete and continuous series. The one who want to refer can use this iCard to go and watch how the mean deviation is constructed about mean in case of individual, discrete and continuous series. Let this be example for individual series where totally five values are given. The data is arranged in increasing or decreasing order, and in case of individual series, for the number of values with odd, for the number of values being odd, the central value will be the median. So once we have arranged this data in an increasing order, the central value here is 20, which is median. And we have the mean deviation formula as 1 by small n, sigma I runs from 1 to n, mod xi minus median. So these are my x values and I'll find out xi minus median and the absolute value in this column. We have x value as 10. So 10 minus median is 20. So 10 minus 20 is minus 10 and the absolute value is 10. Similarly, 15 minus 20 is minus 5 and the absolute value is 5. We represent here. So now as the formula demands, we need sigma xi minus x bar. So we add all these values of this column to give the value 30. Substituting in the formula, mean deviation is equal to 1 by n, where n is equal to 5, the number of values, 1 by 5 into sigma mod xi minus median is equal to 30. So 1 by 5 into 30, which gives the value 6. So 6 is the mean deviation about median, which gives the absolute value of mean deviation. But to find the relative value of mean deviation, we need to use the formula mean deviation by median, which is 6 by 20, that is equal to 0.3. So 0.3 is my relative measure and 6 is my absolute measure. Now let us see an example for discrete series and how the mean deviation about median is constructed. Suppose this is my example for construction of mean deviation about median. Our formula for mean deviation about median in discrete series will be 1 by capital N sigma fi into mod xi minus median. So where n is equal to sigma fi. These are my x values, these are my f values. To find out first median, we need to have the cumulative frequencies. So I find the cumulative frequencies of the given data: 8, 8 plus 12, 20, 20 plus 13, 33, so on. Now to calculate mod xi minus median, first we need to find out median. Median in case of discrete series is nothing but the size of n plus 1 by 2th item, where n is equal to sigma fi. Our sigma fi value is equal to 61. So on substitution, we have size of 61 plus 1 by 2th item, that is equal to 62 by 2th item, which is 31st item. So we need 31st item. Go to the cumulative frequency column, find a value just greater than 31. We need 31st item. So in cumulative frequency column, we'll find a value just greater than 31. The value just greater than 31 here is 33. So this will be my required median class and the corresponding x value will be our median, which we have already discussed. So since we have got median, we'll subtract each value of x from median. So 80 minus, the median value is 150. So 80 minus 150 is minus 70. Its absolute value is 70. Similarly, 100 minus 150 is minus 50 and modulus value is 50. So we'll represent all the values of this column with respect to modulus of xi minus x bar. But our formula here demands for fi into mod xi minus median. So we'll multiply each frequency value with the respective mod xi minus median value. So 8 into 70 is equal to 560, 12 into 50 is equal to 600, so on. So we need to add this column to get sigma fi mod xi minus median, which is 2410. Substituting in the formula for mean deviation, we get 1 by 61 into 2410 to give the value 39.5. This is the absolute value of mean deviation about median. But to find the relative value of mean deviation about median, we use the formula mean deviation about median by median, which is equal to 39.5 by 150 to give the value 0.2633. Now, let us consider an example for continuous series for calculation of mean deviation about median. Let this be the required example for the construction of mean deviation about median. This is our continuous series with 4 class intervals, 2 to 4, 4 to 6, 6 to 8 and 8 to 10. These are our respective frequencies. For given data in class intervals, first we need to find out the midpoints, which is 2 plus 4 by 2, that is 6 by 2, 3, 4 plus 6 by 2, that is 5, 6 plus 8 by 2, that is 7, so on. Now, we need to find out the class intervals because to find median, the formula is L plus H by F into N by 2 minus C, where L is the lower limit of the class interval. To find out the lower limit of the class interval, we need to find the median class first. So, we need to find out the cumulative frequencies. 6, 6 plus 8, 14, 14 plus 4, 18, 18 plus 2, 20. We need to find out n by 2. N by 2 value here is 10. Go to the cumulative frequency column. Find the value just greater than 10. The value just greater than 10 is 14. So 14 decides our median class. The class interval corresponding to 14 will be the median class. The lower limit of this class interval will be our L. The corresponding frequency value will be our F, and H is the difference between upper limit and the lower limit, which is 2. Substitute all the values in the formula for median, that is L plus H by F into N by 2 minus C. L is 4, H is 2, frequency is 8, N by 2 is 20 by 2, that is 10, and C is the value preceding this 14, which is 6. Substitute to give the value median is equal to 5. Once the median is obtained, we find the value of mod xi minus median, that is 3 minus 5 minus 2, and the modulus value is 2. 5 minus 5 is 0. 7 minus 5 is 2. 9 minus 5 is 4. But the formula demands for fi into mod xi minus median. So we multiply the class frequencies with modulus of xi minus median. 6 2s 12, 8 zeros 0, 4 2s 8, 2 4s 8. So adding all the values in this column, we get the value 28. Substitute in the formula of mean deviation, that is equal to 1 by capital N sigma fi mod xi minus median, that is 1 by 20 into 28 to give the value 1.4. So the mean deviation about median is equal to 1.4, which is the absolute measure of mean deviation, whereas the relative measure of mean deviation will be the mean deviation about median divided by the median value, which is 1.4 divided by 5 to give 0.28. With this, we have completed the construction of mean deviation about median in terms of individual, discrete and continuous series, and also the coefficient of mean deviation, which gives the relative measure. In the next class, we'll discuss about how the standard deviation is constructed in terms of individual, discrete and continuous series, and why standard deviation is the most popular and precise and effective value and used measure of dispersion over other measures of dispersion. Thank you for watching and stay connected.